So today's episode is going to be fairly short because we're just going to go back into our game and finish our movement between 2 points for our spider. And then once we've done that, we are going to then flip the direction of what the spider looks like is traveling in. So we're just going to, for that, we're just going to simply flip the image, the sprite, I think it's called, from facing the current location of current direction, which I think is the right direction, to face the left direction when it starts moving in the left direction. So should be fairly simple and fairly quick, assuming it goes right. So let's jump in it. So in the previous episode, we started by trying to figure out which direction we're going in. And I believe I had a Boolean that was called direction right or something like that, but we'll get rid of that because we don't really need that. And I actually found a different way to do this. I'll link the video that I saw this done in the description if I remember, so you guys can follow along with it. If it might be like a better explanation, but to do it, what we're going to need is we're going to need to get a current point. So to do that, let's go and create a transform. So here, this can be a private transform. We'll call this current point. So this is going to be the point that we are currently in, if that makes sense. I mean, it kind of explains itself. So in our update method, let's go and say current point is going to be equal to, what do we want it to be equal to? We want it to be equal to, actually we don't need, let's get rid of that quickly, because we can just use the transform the position.x, because that's pretty much the same thing. So let's try this in a different way. So let's go and say if our transform.position.x is equal to the point B, then we can go and move our, move our spider in the right direction, so in the positive direction, going from left to right. And if it's not, then we can go and move it in the opposite direction, moving from right to left. So now that we've done that, that is still not going to work because we'd have no way of figuring out when our spider actually reaches this point. Well, that shouldn't be doing that. That should be going in the opposite direction. Oh, okay, so it is, we need to go and set that. Okay, so let's go and get our start method back, and then when we start the game, we want to go and say okay, so maybe we do need a current point, so we need to go and say, let's bring this and say private transform current point. And then once we've done that, we can, in our start method, we can go and say current point is going to be equal to point B, like that. Current point dot, actually point B dot transform, like that. Dot transform dot x maybe. And then what else do we need to do? We need to go and say point B dot. Okay, let's just see what's happening here. Why is that not working? Current position dot transform is equal to, well, we probably don't need that. There we go, we need one equals. Okay, so we're going to go and set the current point to be equal to our point B dot transform. And then in our update method, let's just go and play this and see if that makes any difference. I doubt it will. So where's our scene? Okay, so our spider's still moving in the wrong direction. So let's go and see if we need to do anything here. So in our current, in our update method, we need to go and check to see if our current point is equal to, what is it? If our current point is equal to, maybe here, current point dot transform dot x is equal to point B dot transform dot position dot x, then why is that not working now? Transform does not contain maybe it needs to be dot position. Dot position. Okay, so that should be fine. So let's go and save that and let's go and test it out. So if it's, now that shouldn't be correct, so it should move our spider into the right direction. Okay, so now it's moving along the right direction. I don't know why it's stopping. I think it's because it has to do with the... It's not really... It's getting caught on something. Maybe we need to figure that out later on. But now that that's working, now that we've got that working, we can go and actually figure out when we reach this point, because when our spider gets to this point over here, assuming it gets there, it should stop over here and then move in the opposite direction, but we haven't really told it to do anything once it's reached that position. So let's go and do that. So in our update method, we just need another if statement. And this is basically going to say, if we have reached that position, then let's go and swap the direction and move in towards the point A, which I believe is the first point. So let's go and do that. Let's go and say, if the vector2 dot distance. So we're going to do this in a different way. So what we're going to do is we're going to see if we intersect this circle here. So we'll give it a radius, probably about 0.5 or something, and we'll say if the distance between our current position and the current point, which is the point that we set first, which will be point B, so this one. So if our spider's position, so let's move our spider here so that you can see. So if our spider intersects somewhere along this circle here, that means we then have reached that point. So then we can go and swap the current point or current position to the point A, which will therefore move our spider back into the right to left direction. So let's go and do that. Actually, I don't know why I just played that, but let's stop that and go back in here. So here we can do, what we can do is we can go and say vector2 dot distance, and then we can give it the two values. So this is going to be our current position. So transform dot position. Then we need to give it the current point. So the first one is going to be our current point dot position. And then what we need to do after that, we need to go and say, if that is less than, what are we going to give it? Let's give it a 0.2 for now, 0.2f. And then we need to go and say, and the current point is equal to the point B dot position dot transform. Then we can go and flip it. So then we can go and change the value of our current point to be the value of the point A. So let's go and say current point is now equal to our point A dot transform. So that should allow us to... Why is that giving us an error? Okay, so that should be fine. So that, if we go and play that now, we should see that once our spider reaches our point B, which is this point over here, if it gets there, it should then flip. Well, no, it's not going to flip, but it... Okay, that clearly didn't work. Maybe we need to change it over here. So let's see, current... Let's see, why is that not working? Point A dot transform, yeah. So that should work. Obviously, don't know why that's not working, but we'll figure it out. So if the current point is equal to point B dot transform, let's get rid of the x. So point B, let's say like that, and just say current point is equal to point B dot transform. Then rigid body, yeah, that's fine. So if the distance between our current position and the current point dot position is less than 0.2, and the current point is equal to the point B, then current point needs to be swapped to point A. So I mean, that does make sense, but it is not working. So let's just test that again and see. Hopefully the getting rid of the x only makes a difference. No, that doesn't. Okay, so let's go and fix it. Well, not fix it, but let's go and duplicate this. And then what we need to do is we need to swap it. So let's go copy and paste that. And then we just need to swap the point A for point B, and then point B for point A, like that. So if we do that, let's just see if that makes any difference. but I doubt that will. So let's go and test that out and see if that works. So check our scene view, and hopefully, okay, so it's stopping there, but that's not the right place to stop. So it should stop over here. If it gets there, no, it doesn't. And then it just carries on going. Okay, so that's not what we want. Maybe we need to go and say, did I stop that? So I've had possibly had this problem with different projects that I've worked on in the past. So maybe we have to say transform, where are we looking at? Transform.position or current point.local position. Let's try and see if that works. Local position, and we'll copy and paste that onto, where is it? This one. And then we'll just say local position, local. Actually, we shouldn't need to say local position for our transforms or for the current spider. So let's just save that, and then let's see if that works. Not that it will make any different, but let's try it. So does our spider stop? Nope, it still doesn't stop. It still goes in the wrong direction. So our spider is currently at 26, and our point B is currently at 0. Okay, so let's do this again. Let's start the game again, and let's see if we click on our spider. You can see when it gets to this point there, the position of X is 9, and the position of okay, I know why this is. I think I know why this is not working. So let's take point A and point B and drag it up out of this waypoint, because I think that is changing the position of it. So that our point A is at 9 and our point B is at 19. Our spider's X is at 9. Okay, so that should hopefully make the difference. So we can change this back to position, and then we can change this back to position. So adding the parent object is making a difference, because the parent object is located in a different location. So it changes the position of its child object. So hopefully when it gets there, it stops, and it doesn't. Interesting. So let's go and put another test here. Let's go and debug this by printing out. So print, let's go and say point B so we can see if that is actually getting called, and then here we'll just say point A, and if that works, it should only get printed, well, the point A should only get printed out when we reach this point over here. So let's go and see. If we lift that up, make our spider walk, it should get printed up as soon as we reach that point, which it doesn't. Okay, so if we drag our spider back here, where are we at? We are at 19. So where is point B? Point B is at 19.5. Okay, so let's do this. Let's just increase this by 0.5, make it a little bit bigger to see if they actually intersect, and hope for the best. Otherwise, we might have to come back to this. Let's play the game again and see, does it work? Although this spider stopping in the middle of our level is not... Okay, so there it is. Maybe the size is a bit too small. So you can see our spider is now going back. So it should hit there and keep going from left to right. Now we do need to fix this thing where the spider is stopping. So for now, what I'm going to do is I am going to... Can we freeze our spider's position on the Y? So we can put our spider at, let's put it at 0.3 for now. That should be fine. We'll fix it later. I just don't want it to keep stopping. So hopefully that allows it to keep moving from left to right without us having to lift it up all the time. So it should move from left, from left to right, and then back to the left, and then it should keep doing this forever. So we'll set it up like that for now, and then now we just need to go and flip our spider so that it actually faces the correct direction. And then in the next episode, probably in tomorrow's episode, we will start working on the animation because it's not currently running. But let me just fix my light quickly. So give me. Okay, so we're back now to do our, what's it called? Our flipping of our sprite. We need to access the sprite, I believe it is. So let's go and say private. I think it's sprite renderer. Sprite renderer. So we'll call it sprite renderer. And then that's pretty much it. So now let's go back to Unity. And here we can go and drag that in. So on our spider, all we have to do is drag in our sprite renderer, which is, did we make it private? Yes, we did. So we need to go and put this over here and then make it a serialized field so that we can drag it into the inspector. So to do that, let's just open this up quick, scripts. So on our spider, let's go and drag in our sprite renderer into there, and then that should give us access to flip the image. So let's go and say private void flip sprite, something like that. And then here we can go and say if the, I think it's the rigid body that we have to access, if the rigid body dot velocity is greater than, or let's go and say less than 0 minus 0.1 or something like that, 1f. Why is it not working? Let's do on the x-axis. So then we can go and say sprite renderer dot flip on the x-axis. Okay, and then that's going to be equal to true. And then we can just simply copy that entire thing and say if it is greater than 0. What am I saying? Great, what I do? If it is greater than 0.1f, then we don't want to flip it, so we'll set that flip x to equal to false. So let's test that out. So now we can just simply call this in our update method, and here we can say flip sprite. So hopefully that works, because I remember doing that in one of our other episodes, but that was completely from memory. So hopefully that actually works. So let's test it out. So let's play the game, and let's go and watch our spider move from left to right. So it should, once it reaches here, flip direction. Okay, so that's working nicely. So make sure it does it the opposite way. So that's perfect. Alrighty, so that is how we are going to, for now, make our spider move from left to right and then back to the left direction. But maybe in one of the further episodes down the line, we will change that depending on our movement that we want our spider or our enemies to do amongst the levels. So, but for now, that's a temporary solution just to add a level enemy into our level. And yeah, that's gonna be it for today's episode. So tomorrow we will start working on the animation, and we also still need to go and fix the sprites, not the sprite, the platform spike tile that we created with the tile rules. So we'll get on to working on that and try and fix that if we can. But for now, if you haven't done so already, please go ahead and hit this button over here to subscribe to the channel, and I'll see you guys in the next episode. So thanks for watching. Goodbye.